And another characteristic of radiant energy is that it runs devices cold. No heat's generated in the coil. Like this coil could run for, we could run very high voltages through it and it will never get hot. I saw a demonstration out in California back last fall by a guy by the name of Pete Summerock, who has developed this amazing solid-state device that has a measurable COP of 70,000. And COP, or coefficient of performance, is a measurement that's most commonly heard of with heat pumps. And in a heat pump, let's say common figures are anywhere from between a COP of 10 and a COP of 16. And what that means is that the measurable energy going in to run a heat pump is, or the output of it, I should say, is 10 to 16 times greater than the amount of energy required to run the device. But what those measurements don't say is that it's absorbing energy from the environment. Well, that's heat energy in the ambient air. But in this case, this is absorbing the radiant energy from the local environment. And although on one of the discussions that took place today, I think it might have been Gene Manning, that said there's no measurable way of determining radiant energy field. A friend of mine down in Florida has invented a device that can detect and measure the relative strength of a radiant energy field. So now there is a device that can do that, but it's not in production. He's given me permission for the production rights to it, but I haven't begun doing it yet. But that's plans for the future. Another characteristic, back to Pete Summerock, his device that was running on two number 24 wires, which are like tiny little telephone wires, were running five motors that total 20 horsepower. And in a 15-minute demonstration, those motors never generated any heat whatsoever. And the device itself, although it had a huge heat sink on it that was about this deep and about this big, generated no heat whatsoever. And in using normal electricity, you can't run a motor for 15 minutes or draw enough voltage to run 5 motors without generating a tremendous amount of heat. So that's one of the characteristics of radiant energy. And the third characteristic is that when you see the sparks coming from regular electricity, the sparks are generally yellowish white, and sparks from radiant energy are bluish greenish. And so whenever you see on a commutator, you see sparks flying that are bluish greenish, you know that there's radiant energy in the system. Although most motors run that energy to ground, they don't take advantage of the mechanical gain that you can get from it. Bedini, that's what one of Bedini's discoveries, or rediscoveries, I should say, because Tesla did this over 100 years ago, that modern motors and modern electronics, although in many cases will introduce radiant energy into the system, because it's all run to ground, it doesn't produce any useful work. But by having it, by setting up a circuitry like Bedini has, then you can put it to work, and it can actually measure over unity. And that's pretty much what I have to. Are there any questions?
How do you spell Summerock?
S-U-M-A-R-U-C-K. Yes.
I recall from a gentleman I met over at Bell Labs some years back. He measured the atmosphere electricity that, if I got it correctly, it's 0.5. Now, I don't know if that, because it's been some years, was that whether he was talking voltage or amperage at that point?
I
But
don't,
he used parts from one of those old Geiger counters from the Civil War or Civil Defense equipment
oh.
to do it.
Now, I'm not sure exactly what you're referring to, but I do know in one of Bedini's publications that he co-wrote with Tom Bearden, he shows a setup. He shows a setup where you can take a 200-foot long wire at an elevation of about 30 feet, and using a SCR, a silicon controlled rectifier, and capacitor, you can get a voltage difference of 200 volts. Now, because that 200 volts is at practically zero current, it can be used for charging batteries or charging capacitors, but it's not like 200 volts out of the outlet in your home, but it can be put to useful work. Now, Tesla ran things off of a similar kind of device in his day, but I'm not exactly sure what Tesla's setup was like, so I'm not.
Are you gonna measure that with your ammeter?
I was gonna measure that.
Why don't you do it now?
I'll do
There's our
it
witnesses.
right this moment.
But I'll handle the mic while you're doing the testing. And you can also take the numbers that you had from the original numbers, you can call them out. What was the original numbers, Tom?
Okay, the running battery was at 13.1 volts, and the charging battery was at 12.31 volts. But at that time, I didn't have an ammeter with me that could take an accurate measurement, and so I didn't take the amp measurement. This morning I did, and by this morning, the running battery was at 12.7 volts at 0.17 amps, and the charging battery was at 12.78 volts at 0.41 amps. So we'll see what happens now.